Hi everyone, welcome to Skilled Inspirational Academy. This is free CCNA day 8 class. These are all the topics we are going to discuss today. We'll start with router on a stick. So let me open a packet tracer. So before that, I'll give an overview about what is router on a stick and where the router on a stick deployment has been done. Okay, this is similar to your inter-VLAN routing, but the key difference is, in the routers, we all know router ports are very limited ports. It's not like a switch. Switch got 24 port and 48 port switches. But if you see the routers, we got very minimal ports. Because the router will not do switching. So the main purpose of the router, it does routing and it connects to different LAN. We all aware about this because in the previous classes we discussed about that. So switch, it connects, in the VLAN, the concept of VLANs, you can divide into multiple broadcast domains. That's the use of switch. But if you want to have a WAN connection, and if you want to connect two different networks, and if you want to make the internet connection possible for your PCs, that's sitting beneath the switches, you have to have a router. They call it as a head end router because that's where your WAN connection goes to the internet, right? This is cloud. Through, if you want to connect to internet, you definitely have a router. So in some deployment, we are aware that we got a multi-layer switch. It does both L2 and L3, both routing and switching. But in the router, maybe before this L3 switches, so the router is being primarily used, to connect multiple networks before this L3 devices. That depends on the requirement. If if your budget is too less and if you want to make your network with one router, but pretty simple, this is one L3 device and one L2 device, they'll go for a router and a switch instead of a multi-layer. So it all depends on your requirement and your design. So we can design in this lab. Is the objective of this lab is how you can create multiple logical ports in a router and how we can use it. So what is the protocol used if we create a logical interfaces, and how this communication happens between the switch and the router, how it both interconnect and work together. So why they call it as a router on a stick? Why? Because you got a router and you got a switch, and all your gateways are sitting in your router. But I got only one interface, one physical interface, right? But how this communication happens between the switch and router if I got one interface? We all aware that if we got, say for example, we got 3 VLANs. So for these 3 VLANs, I should have 3 gateways. How do I achieve with one physical port? That's where the sub interface comes in. Sub interface. Also, people call it as a logical interface. So I'll make use of one physical port and make multiple logical ports. That is possible. In the same way, how inside your trunk link, we got more 2 switches. Yesterday we discussed, and we got the trunk link that's running between the switches. So inside the trunk port, we configure 802.1q. We enable this protocol. So what it does, it carries the VLAN information from switch 1 to switch 2. That carries multiple VLAN informations, right? That's tagged inside. In the same way, inside the router, with a one physical interface, say for example here fast Ethernet 0/0, I'll logically create one more interface, fast Ethernet 0/0.1. That's your logical interface, not your physical interface. You cannot see this. This is logical. How we got the PCs with the logical ports. Your PC is communicating with the logical ports, right? Your source port. Every time it's dynamically generated and it's been assigned by the operating system. In the same way, you are creating this logical interfaces. Actually, it is not, but you're creating a logical interface. You cannot see, but with the config, you can go through the logical interfaces and the configuration that's been done inside the particular interface. So this is the ideology of logical interface. So next, why I need a logical interface? What is the benefit of using this design? And I would say, what is the purpose of this design? Since I got one physical port, but I got 5 VLANs in my switch, VLAN 10, VLAN 20, VLAN 30, goes on till VLAN 50. So I got 5 VLANs. It means I got 5 broadcast domains. For this 5 VLANs, I should have an L3 connection, right? My gateways. I should assign an IP address. So how do I assign with one physical port? Maybe here in this example too. But how can I, provision VLAN 30, 40, and 50? I'm running out of port, right? I do not have much ports to be configured as a gateway for other VLANs. So instead, I am making one physical port chunk into multiple logical ports. As I need, based on the requirement. As per my need, I'll, create as many logical interfaces. That's possible. And it's when you look visually, this looks like, there is a stick on the router. So that's the naming convention they give. Generally, there is one connection that's on the router, so they call it as a router on a stick. Let's see the configuration, the configuration steps that should be carried out to make the router on a stick up and running. So for that, let me create a lab with one router. So I'm going to create 3 VLANs. I got a switch. Let me connect the devices. Done. Let me log into the router. Let me zoom in a little bit. We try to see a logical connection. So I got only one connection, right? This gigabyte port that's going back. This is gigabyte 0/0. And the destination port is fast Ethernet 0/4. And all my PCs are connected in this port. When we come down, I think we can see PCs. Okay, this 4 cables that's going back to the PCs. This is how the physical connection is about. Let me go back to the logical topology. Okay, let me open a router now. I'm not interested in the default configuration. I go to enable. Let me see the ports connected to the switch. So I got only one port, gigabyte 0/0. I'm going to configure this. So the command, I'm in the configuration mode and I'm giving gigabyte 0/0, right? Followed by, you give the question mark, dot. Yeah, you should give a dot and then followed by the question mark. You can see the sub interfaces that can be created. It's huge, but we are just going with one or two as per our topology. So let me give .1. So now can you see I am inside the sub interface command. So this command created my sub interface. So I'm inside the sub interface. So the configuration, whatever I do now, that's going to, apply to the sub interface, not to the physical interface. This is important. So before that, what should I do? I should make the physical interface up and running. I should make the physical interface up and running. So what is the command that should be used? Interface gigabyte 0/0, no shutdown. Physically, I'm making this port up and running. So how do I verify that? Show IP interface brief command. Can you see that? So the gigabyte 0/0 is up and running. I see green lights here. The port is active. And along with that, if you see this, I didn't bound this port. All you have to do is you have to bounce your physical port. There is no need of, bouncing your logical ports because that's logical. That's not physical port. So I am inside interface GI 0/0. And then I gave no shutdown command. So the port is operational because that's connected to my switch, right? And I have created the sub interface GI 0/0.1, the first logical interface. I didn't give any command here, but the port is operational. Why? Because the physical port is up. This is logical. So that's it. That's the configuration of the sub interface. So what should I do now? So my ideology is to create 3 VLANs. So what are all the VLANs we have planned to create? VLAN 10, VLAN 20, and VLAN 30. So I need 3 gateways. So what I'm going to do here, so this GI 0/0.1, that's for VLAN 10, and I'm going to assign an IP address. For what? This is for VLAN 10 gateway. And I'm going to create one more interface, logical interface, and I'm going to assign an IP address for VLAN 20. Right? This is going to be a gateway for VLAN 20. The same way, VLAN 30 gateway. I'm going to create one more interface, GI 0/0.3, and I'm going to assign an IP address, and it is a gateway for VLAN 30. All from the primary interface 0/0. This is my physical. right? Let's do that. So configure interface GI0/0. I should not assign IP address here. That's important because this is just my physical connection that carries my data. So how do it exactly looks like? I got a router and I got a switch. And I have created 3 subinterfaces, right? GI0/0.1, .2, and .3. And this physical interface GI0/0, I'm not going to configure anything. But I made the port operational because this is physical port. This is up and running. But inside the logical interfaces, I'm going to assign the IP address. This is important. But if you are not bouncing this port and this port is not physically up, all your logical information will not be, send it across. Because physically the port should be up and running. That's a primary thing you should do when you do a config. So interface GI0/0.1, my first interface. I'm going to assign an IP address, but before that, I have to enable the encapsulation. .1q followed by the VLAN ID. So what is the VLAN ID I'm going to create here? VLAN 10. That's it. If you have your native VLANs, as we discussed yesterday, you can do, but here I'm not going to do anything with the native VLAN. I'm keeping the native VLAN one as the default. So let me do the config. So once I enable this, only then you can assign an IP address. If you're not enabling the encapsulation, you cannot assign the IP address. If I try to give IP address 10.0.0.1, 255.0.0.0, it says IP routing on LAN subinterface is only allowed if that subinterface is already configured as a part of .1q. Since I haven't enabled .1q, it's not allowing me to create the, allowing me to assign the IP address. So I have to enable the .1q first, and then I can assign the IP address. So encapsulation .1q followed by the VLAN number, VLAN 10, no native VLAN, enter. And then if I assign the IP address, I will not get any errors. It will pick the IP address, whatever I assign here. So no shutdown is not needed. That's up and running. So the second step, other subinterface for VLAN 20. Encapsulation .1q VLAN, not VLAN, .1q followed by the VLAN ID 20. Enter. IP address 20.0.0.1, 255.0.0.0. This is default subnet mask /8. Enter. No shutdown. No shutdown is not needed. So physical, sorry, logical. Then GI0/0.3, third subinterface, and encapsulation .1q followed by the VLAN ID 30, IP address 30.0.0.1 and 255.0.0.0. Enter. I have to verify, right? The interface is whatever I created. Always give show IP interface brief command to check your physical status along with your logical configuration. So I have assigned 10.0.0.1 and so my status is up, protocol is up, so this is fine. The same way for 20.0.0.1, 30.0.0.1. So my port configuration is successful now. So what should I do next? I have to go into my switch and create the VLANs, right? Log into the switch, enable. I have to create only the L2 VLANs, not L3 VLANs, because I have configured all my L3s on the router. So only I'm going to configure the L2 VLANs here. So it's VLAN 10, VLAN 20, exit VLAN 30, the configuration mode. How do I check that? Show VLAN. So I have to assign the ports, right? That's the second thing. Once I am done, I should configure the ports. So fast Ethernet 0/1 is for interface fast Ethernet 1. Let me go to config mode, interface fast Ethernet 0/1. Switch port access VLAN 10. Done. And then fast Ethernet 0/2. Switch port access VLAN 20. Then followed by fast Ethernet 0/3. This is for VLAN 30. VLAN 30. How do I check that? Show VLAN command will show me the ports assigned to it. Maximize this. Fast Ethernet 0/1 is assigned to VLAN 10 and 2 and 3 accordingly to VLAN 20 and 30. That's it. I'm done with the configuration. Let me go back to the PCs. So I'll do one thing. So we have a separate DHCP lab. I'll try to build a DHCP server here. And I'll explain about the DHCP. Go back to services, DHCP. So this is the server you can utilize this server. If it is inside the endpoint, you go to the end devices, you can see the server. Server is generally what it's you have many servers running inside, right? You got your web server, you got your HTTP web server, your DHCP server, your TFTP server, DNS. So you can play around with the server. Now I want to make this as a DHCP server. Let me, turn on the service. Let me give a name, something like test. Make it as DHCP. DHCP and the gateway is 10.0.0.1. DNS, no DNS server at this point. Can give 10.0.0.1. And the starting IP address is 10.0.0.1. Sorry, 10.0.0.2, because I have assigned the 10.0.0.1 IP address to the gateway, so it should not be included here. So the default subnet mask value is 255.0.0.0. So let me add this. So I got it. So maximum 512 users can get the IP address from this DHCP server. Let me go ahead and connect this back. And now the ideology is this PC should get an IP address from this server. So let me go inside, but before that, I have to make this port as access port VLAN 10. So as we discussed yesterday, what happens? Discover is a broadcast. So this PC in the left, this PC in the left, it's going to send a DHCP Discover. What is DHCP Discover? It's going to send, hey, I don't know the IP address, somebody help me. So it's a broadcast. It asks for everyone in the network. switches, your router, all your PC. It sends a request to all the end devices in a network. So since I have configured this server as a DHCP server, this is Discover, right? This is going to send an offer message. This is going to offer the IP address, example 10.0.0.3, and this is your subnet mask. Since I have configured the gateway, it will give the gateway address. See, all these three parameters you need to communicate to this network. So this is going to offer this message back to this PC because I got a Discover here. This is very important. Discover is a broadcast, but offer message is a unique cast. Because from the DHCP Discover broadcast message, I know where the request has come from based on the MAC address. So it knows exactly where to send this back. So Discover is a broadcast and offer is a unicast. So once it receives the unicast, it's going to discover, offer, and then it requests. Okay, I am fine with all these details. I can consider this IP address as we discussed yesterday, the same concept, just a recap for better understanding. So once it agrees for all these parameters, it's going to send a reply back. That's a request message back to the server. Okay, fine. I'm fine with the IP parameters, whatever you suggested to give me. I'm fine. I'll take up the IP address, whatever you give. And once the 3 handshake is done, it's going to send back an acknowledgement. This is called DORA process. Discover, offer, request, and acknowledgement. Discover from client, offer from server, request is from client, and acknowledgement from server. 4-way handshake. Very important question. They ask how the DHCP process happens and what is the DORA process and what happens in every handshake. What is the information exchanged between the client and the server? So this is DORA process. It's done. So let me go inside the PC. Let me try to get the DHCP IP address. So I think I haven't done the port configuration. Right. So how do I check that? Show run fast Ethernet 0/5. I haven't done any configuration yet. Interface fast Ethernet 0/5. Switch port access VLAN 10. How do I check that? Show VLAN. Show VLAN. Give me the ports that's bounded. So fast Ethernet 0/1 and 5 has been assigned to VLAN 10. Now let me go inside the PC and try to do a DHCP Discover. Let's try we do any packet capture. We got DHCP here. They made it as telnet, my ACLs, radius, HTTP, nothing. Try with 4. Only okay, I got the DHCP here. So let's try. It's sending a Discover. Still requesting DHCP. and it's failing in the switch. Why the ports are still negotiating? Okay. One more thing, the uplink port, the port which is connected to the router here, it should be trunk. Why? Because all this information the router is sending back to the switches, right? To the switch, right? You got VLAN 10, 20, and VLAN 30. So you got VLAN 10, VLAN 20, and VLAN 30. 3 VLAN information tagged inside one single port. So how do I understand this? You're talking on, when this is something like both should speak in the same language. You're talking about .1 queue. I should be aware about the .1 queue protocol. Only then I can understand whatever you're saying, right? So in the same way, if I enable this trunk, so automatically it enables 802.1 queue. So I receive the VLAN informations inside. Only then if the port is medicine. If the port is running as a trunk port, so once it is done, the .1 queue will be enabled inside. Let me delete this. And let's see, the PC got an IP address, it got an APIPA IP address. Let me set a discover message again. It goes to the server and I'm not receiving an IP address. I'm getting an APIPA IP address, automatic private IP address. Why is it my discover message is failing somewhere? Let me go back to the PC. And see, the client IP address is all zeros because I didn't get an IP address, and the server, I don't know anything about that. It's all going to be a broadcast, right? Say this is layer 2 broadcast because I don't know where the DHCP server, this is called as layer 2 broadcast, all Fs. It's sending the DHCP broadcast to all the L2 devices because I don't know anything about the server. This is layer 2 broadcast. So the switch will forward this to all the connected devices except the incoming port. Say for example, this is your switch and I am receiving a discover message on this port, incoming port. This PC is sending a DHCP discover. So it broadcasts this out to all the devices because it purely works on layer 2 and all this device receives this discover packet. And only the DHCP server will respond back because I am running DHCP service on this specific server, DHCP server. Let me troubleshoot why I am not getting an IP address. This is the port number used for DHCP. So your DHCP works on layer 7. These are all the key points you should understand. This is your well-known ports. UDP port 68 and 67 used for DHCP. How do we differentiate? We got a web server that's running HTTP service that's running on port 80, right? So only the port, if I'm sending a DHCP request, my HTTP server will not reply back. The web server that's interested to listen on port 80. So now, since I have configured the DHCP server, the logical port, this is logical, you cannot see. This logical port inside the operating system, they embedded to receive your DHCP discover messages, 68 and 67. So it listens the DHCP discover message on port 68 and 67. Such a port number shown here. Let me try why I am not getting an IP address. So what happens? This is actually going back. I'm sending it discover and it should receive. Let me check the port configurations. Show run. So this is assigned to VLAN 10. What is the gateway I have assigned here? 10.001. Okay. So first thing from this, let me try to I'm trying to find the command prompt inside. This is a server, no options for the command prompt. Okay, let me try to ping from this router to this server, right? That makes sense because I have configured the gateway here. So ping, so what is the IP address I gave for this? DHCP server. So this is not yet assigned. I'm running on this and it's connected on fast Ethernet 0/0. The default gateway in the DNS server I have defined is 10.0.0.1 and the starting IP address 10.0.0.2. Let me remove this. This is active. Okay, we reached the buffer. Let me stop this. Okay, let me check the configuration inside fast Ethernet 0/5. This is on VLAN 10. So I have assigned the ports. Everything is fine, but I am not receiving the DHCP. Okay, let me assign static IP address here, 10.0.0.5. Default gateway is going to be 10.0.0.1. I think I have been assigned the IP address. That could be a problem. Okay, I got an IP address, but why it's not sending me the gateway address now? So this is how you should troubleshoot. You have to check all the possibilities. If you understood what we are doing, then definitely you'll get to know. I have given the gateway here, but still I'm not receiving a gateway address, the DHCP. Let me try to do a simulation back again. Let me go back to DHCP Discover again. Okay, it received. Let me stop the simulation mode. Go back to real time. I think it is definitely a bug with the packet tracer because we have defined the gateway here. It's on the same subnet. Let me turn off and turn on again. Okay. Anyways, so let me try. Did I keep the gateway here? (10.05) and 255.0.0.0. I gave a gateway here. It's not sending me the gateway back. Is it configured on fast Ethernet 0/0? Okay, this is the Okay. We have added this. Nothing pending. We done everything. I don't know, maybe packetry is a problem. Okay, let's try other way of doing DHCP then, because we need a gateway for the communication. Let me go delete this and create a DHCP server in the router. The router can also works as a DHCP server. You can run the DHCP service in the router, but in the enterprise, since they have to, there is a dedicated DHCP server because it cannot receive in a huge DHCP request back that will, degrade the performance of your router. So it's always recommended to have your dedicated DHCP server. So I have to create a pool, that's Cisco. And then the second thing, I have to give a default gateway here. That's 10.0.0.1, right? And then define your network. What is the network I'm going to use? The pool, right? I gave a name for the pool, Cisco, and the network I'm going to use is 10.0.0, followed by the subnet mask, default subnet mask 0. Then my DNS server is going to be the same, 10.0.0.1. That's it. And here I want to talk about a little bit about the options. In the production network, they use this option codes. So every vendor, they have this, this is all the when they do an application, or if they do some kind of development with regards to DHCP, they stick to a specific code. So here in the upcoming classes, we learn about WLC. So once a PC, once the access point, if it is connected to a switch, imagine just for an overview, we'll discuss in detail in the upcoming classes, but I want you guys to, help you to understand about the real world scenarios, use cases. So when you connect an access point, it's a wired connection between a switch and the access point. And once the access point is connected, how do the access point know about the WLC, the wireless LAN controller? That's the master that controls all your access points. So they call this as a lightweight access point. For your information, an overview. So if this access point wants to communicate back to the WLC, it will make use of the option 43. So once the DHCP request comes with option 43, that's been added to the DHCP header, the DHCP Discover header. This forwards this back, the DHCP server relays this back to the controller, and it say, hey, this is your controller IP address, you get it, because you sent a request with option code 43. So this is a use of option code. So for every vendor and for the voice services, they use option for 150. The same way, based on the requirement, they use this. But mostly in the network perspective, the data perspective, they use option 43, and for voice they use 150. A quick overview about DHCP options. So I created all this. Now there is no specific option. So how do I check my DHCP configuration? 3 key things. I have to create a pool, the name, and I have to create a network and my gateway, default router, and the DNS server is going to be the same. Okay, once I'm done, I'm going back. I'm requesting a DHCP again. Turn on my simulation. See the actual packet that hits the switch. The switch, since the switch is configured as a trunk port, this DHCP Discover message has to go all the way back to the router. That's expected. Did I make the port as a trunk? Show interface trunk. No. So my traffic is blocked in the switch because I haven't configured the trunk port. Interface fast Ethernet 0/4. When you do lab, just try to do in the same way. Run your simulation and try to find. Okay, from here I can understand there is something blocking my switch. The traffic is not forwarded. The packets is getting blocked in the switch. It's not going above the switch just because I didn't configure trunk. So switch port mode trunk. So now the negotiation is happening between the router and the switch port. So my trunk is up and running. Let me go back to real time. Now again, simulation. Let me start my simulation back. Can you see this? Now the PC got an IP address with DNS information. So here the ideology is to, learn about DHCP plus router on a stick together. So now we understood, right? So the discover message has been sent here. See, this is very important. There are two types of architecture. So in the upcoming classes, we got one more architecture, that's spine and leaf architecture. This is, we all know this is tier 3 architecture, right? Okay, here we got only one L2 switch, but in the actual tier 3 architecture, we got one more multi-layer switch. They call this as a distribution layer. We learned about that, right? Just a recap. So the DHCP Discover has been sent from this PC. It's going all the way back since no trunk port, it's get blocked, and we done a trunk, and the packet reached the gateway where fast Ethernet 0/0.1. So once it received this, I have the DHCP service running on this router. For this Discover, I got an offer. Request and acknowledgement, all 4 phases done. And I got an IP address with gateway and DNS since I configured everything inside. One more important one more important thing to consider here. In an interview, they will ask a question: how do the PC get to know about your DNS server? See, inside your DHCP request, there is one more request for DNS. I'll show you the packet capture I got. I'll show you the packet where we are asking for the DNS details in the DHCP Discover. Yeah. For now, so that's how you get it. So in the DHCP request, you get auto IP address along with your DNS. That's important. So I got an IP address. Now let me check the communication. So what is the IP address of this PC? I haven't configured. I'll do a static configuration for all the species. Go to config, and this is VLAN 30. So 30.0.0.5 default subnet mask. And I'm giving 30.0.0.1. No DNS server for this network. To close this, go to second PC and configure an IP address 20.0.0.2. and 20.0.0.1 gateway. Let me give it 5. Done. Let me test the connection. Go to desktop, close this, open my command prompt. First, let me ping my gateway 10.0.0.1. It's sending an ICMP request. No response. Let me go to this PC and ping 20001. What happened? Okay, I got a reply. Packet traces. I mean, we got so many bugs inside packet traces. Are we running into simulation? Come back to real time. Okay. Okay. Ensure that you're always running on real time mode. Simulation mode takes much time. Okay. From here, let me try to ping this PC. Ping 2005. I can ping. So I'll show you. This is very important. Let me go back to simulation and let me try to ping 20005. So let me start this. My God, it's giving a lot of error. Start. And I didn't add the ICMP here. Okay. Start. Can you see this? This is going back to the gateway. Coming back again. Because this tier 3 architecture communicate from bottom to top. The species cannot communicate like this. This is called east-west traffic. This is bottom to top. All the conventional tier 3 and tier 2, you got your gateway going back and it goes to the destination. It cannot communicate directly to each other. Interview question. What is east-west traffic and what is the bottom to top approach? So done, we verified the connection, the router on the stick is working. So a quick recap what we did. So we configured three L3 interfaces here inside the router. Let me stop this. Come back to real time. Delete this. So I got 3 gateways inside the router. 10.01, 20.01, 30.01, and I've enabled the encapsulation .1 queue. Only then it understands about the VLAN information. And I made a trunk port here to send and receive the .1 queue information. Inside the .1 queue, I got my VLAN 10, 20, and 30 informations. Right? Can you see in the top? VLAN 10, 20, and 30 inside. And I made the ports accordingly for VLAN 10, 20, and 30. That's it. So once I am done, along with that, we discussed about DHCP. What is DHCP? Is dynamic host configuration protocol. Yesterday we discussed about the theory part and we did a lab. And I'm running a DHCP service inside the router, and it's working as a DHCP server. And inside the DHCP request, discover request, actually I request for 2 information, not 1 information. This is important. I request for DHCP along with DNS information, both together. Now I'll show you the packet capture, the real-time packet capture of DHCP. So what is a protocol? What protocol the DHCP uses? Very important question you'll get in your exams along with the interview questions. It uses UDP protocol. Can you see this? It uses the UDP protocol. And what is this port? This is for DHCP. And you see this source all with zeros, because this is the first packet that goes from my PC. This is my PC, and this is the DHCP server. So it's a broadcast, layer 3 broadcast. And if it is all 255, it's L3 broadcast. If it is all F, layer 2 broadcast. Key point. So it's a discover, right? From this is my source and this is my destination. This is my PC. Since I haven't received any IP address from the DHCP server, it's sending a broadcast out. Right? So what is inside DHCP? Client IP address, nothing, because I haven't received any IP address. Next server IP address, I don't know. What is a relay agent? We'll discuss later. But for now, if you actually see this, what are all the information inside? So DHCP option 53, this is discover message. 61 for client identifier. It's just saying it's, hey, it's me. How it distinguished the packet. So inside this DHCP discover message, I got this option 53, option 61, 11, 12. But the key thing you have to consider here is the option, option 12 is your host name and the client identifier 61, and option 53 for discover. So what is inside the offer? See, this is offer message. Do you see here? This is a broadcast, but here, see, from this is a DHCP server. Okay, this is again broadcasting out offer. So what is the client MAC address? It got this detail from the discover. And along with that, can you see this option 6? But when the PC, it sent out a discover message, my intention is not to get the DNS, but the offer packet, it's giving the DNS server details as well. Can you see this DNS server details? It's option 6, and it's giving a subnet mask value. Right? We discussed what is the IP address, the subnet mask, all this information inside the offer packet. So once this is done, what's next? Request message again from, because this is offering the IP address, but till now this PC haven't picked up this IP. So what is inside the request message? Since the client IP address, server IP address, nothing. So what is inside the acknowledgement? See, I got an IP address now, the acknowledgement. So once it's offering and it's requested, okay, I'm fine. I get the IP address, whatever you're offering now. So now the client is getting an IP address. Right? And the DNS server details, the subnet mask value. It's worth to take a look on the packet flow. If you understood this, again, this is a broadcast, L2 broadcast. So once you go through the packet flow, only then you get familiar with you can visualize more. Do a lab, do a packet capture, learn, and you will be very good in your understanding about any concept. I would recommend always to learn with packet capture along with the lab and theory. That makes you more stronger. You can be a competitor in your interview. So that's more about DHCP and router on a stick, 802.1q. So I have a plan to discuss about TCP, IP, and OSI model, but I think we are reached. So we'll have this discussion in the next class. And I hope definitely you guys enjoyed today's class. We got a packet capture, we got, we done a router on a stick lab and we troubleshooted the issue. And this is more practical, right? I hope everybody enjoyed today's class and understood better. Okay, guys, thanks everyone for watching today and have a great weekend. And we will have one more Q&A session on Wednesday when you do your labs on weekends or whenever you feel to do a lab, do it. And if you have any questions in the Q&A session, we will discuss about that. So until that, thanks so much. And we'll catch up on the next class, yeah, Monday. Have a great day then.